Good day to everyone. My name is Liza Jane Tan. I am a reporter from Group 2, and I will be discussing how computers store data storing characters. Let's begin. This presentation explores character encoding. We'll uncover how computers store text, learn about encoding characters ASCII, Unicode, UTF-8, and UTF-8. Let's begin. Binary. This system represents data with zeros and ones. Each zero or one is a bit. All data including characters becomes binary. 1 represents on and off represents 0. Bits and bytes. A bit is the smallest unit of data. A byte typically contains 8 bits. Bytes store small pieces of information. They are fundamental for memory management. So the bit is the smallest unit of data, while bytes contains 8 bits and kilobytes contains 1024 bytes. Moving on to encoding characters. ASCII standard. ASCII is an early character encoding standard. It uses numbers to represent characters. Each character corresponds to a unique number. It has a limited range of 128 characters, and it has simple mapping, each character to a number. Though ASCII has limitations, ASCII's limited range restricts the characters. It does not include many languages letters. Special symbols are also missing. This limit creates character encoding challenges. Moving on to Unicode. Unicode includes almost every character and symbol. It overcomes ASCII's limitations. Unicode supports diverse languages and scripts. It is now a global standard. Comparing Unicode to ASCII, Unicode is more of a global, versatile, and comprehensive. Supports more than the ASCII, which only supports English characters and limited symbols. Whilst Unicode can support more than that. It can also support many other languages around the world. Also regarding Unicode, Unicode has a character encoding system, UTF-8. UTF-8 is a Unicode character encoding system. It uses variable length encoding. UTF-8 is compatible with ASCII. It optimizes storage for English. Moving on to storing text data in computers. Computers store text using character encodings. First, the computer maps characters to numbers. Next, it encodes numbers into binary. The binary data is stored into memory. Practical applications and examples of these are web pages, databases, and text files. Character encoding is essential for web pages. It is also critical for databases. These files require correct encoding to display data properly. Programs use encoding to process text. In conclusion, character encoding is fundamental for computers. It enables text representation and processing. Understanding encoding helps prevent character errors. Use UTF-8 for global compatibility. That's all. Thank you.
Advanced number storage is a modern method and technology used to store and process large, complex, and high-precision numbers efficiently. This method is crucial, especially in the field of scientific computing, cryptography, artificial intelligence, and big data processing. In storing number, we have two different binary presentation methods. The two's complement and the floating point notation. The two's complement is a binary number presentation method used in computing to store and process signed integers. It is the most widely used method in modern computer systems because it simplifies arithmetic operations and allows efficient storage of negative numbers. For example, if we store negative 5, in binary it is 0, 1, 0, 1. Then we will find the ones complement. For this, we will convert 1 to 0 and 0 to 1. Then add 1 as those complement. So 0 plus 1 is 1, then copy. To confirm that it's a negative number, the first one must be in a negative sign. So negative 8 plus 2 plus 1 is equal to negative 5. And that's how we solve for 2's complement. Floating point notation is a binary presentation method used to store and process real numbers or positive numbers in decimal values efficiently. It allows computer to handle very large and very small numbers while maintaining accuracy, making it essential for scientific computing, graphics, AI, and high-precision calculations. It includes 1 bit sign, 8 bits exponent, and 23 bits mantissa.
Good evening, everyone. Our topic for today is other types of data, which is text data, image data, video data, audio data, and binary data. The first one is text data. It consists of characters, letters, numbers, and symbols that make up written language. It also can be stored in plain text files or formatted documents like Microsoft Word or Google Docs. The second one is image data. Image data is a visual representation of object or scene. It can be photographs, illustrations, graphs, charts, or diagrams. It can be stored in various formats like JPEG, PNG, or GIF. The third one is video data. Video data is a sequence of images displayed rapidly to create the illusion of motions. It includes movies, TV shows, or recorded video footage. It can be stored in format like MP4, AVI, or MOV. The next one is audio data. Audio data consists of sound waves captured and stored as digital signals. It includes music, speech, and sound effects. It can be stored in format like MP3, WAV, or AAC. The last one is binary data. Binary data consists of 1 and 0 that represent machine language instructions. It is used to represent program code, executable file, and other data processed by a computer CPU. These data types are stored in digital form using binary code, which is processed by the CPU and stored on various storage devices like hard disk drives, solid state drives, or flash drives. So that's all. Thank you for listening.
Good day, everyone. My name is Elijah Jane Ardarasma, the reporter of Group 2, and today I'll be presenting from machine language to assembly language. So, in this presentation, we will explore machine language, how it works, its advantages and disadvantages, and how assembly language makes programming easier. So, let's get started. What is machine language? Machine language is defined as a collection of bits to be read and interpreted by a computer. It is the only language understood by a computer. So, machine language consists of binary code, which is the zeros and ones, here in the example, the picture, that a computer directly interprets or communicates with hardware, but it is difficult for humans to write and understand. Since computers only understand this language, it is considered the most fundamental level of programming. So, how machine language works? Machine language works, computers processor reads the binary instructions and executes them step by step. Each instruction tells the computer what to do, like adding numbers, moving data, or displaying information. Since there are no words, everything is presented as patterns of zeros and ones. So let's move on to the advantages of machine language. Direct hardware control. Machine language allows programmers to directly manipulate the computer's hardware, providing fine grained control over system resources. So it provides precise control over the computer's hardware and efficiency. Because it's the language the computer directly understands, machine language programs can execute very quickly and efficiently. So it runs faster than higher level languages since there is no need for translation and compact code. Machine language programs tend to be smaller in size compared to higher level languages as they are closer to the hardware level. So compact code, it is smaller in size compared to high level languages. And direct memory access, machine language allows for direct access to memory locations which can be useful for certain tasks. So it allows direct manipulation of memory locations. And so let's move to the disadvantages of machine language. Mm, Complexity. Machine language is extremely difficult for humans to understand and write, as it consists of binary code, which is zeros and ones. So, complexity, writing, and understanding binary code is very challenging. Lack of portability. Machine language programs are highly specific to a particular type of computer architecture, meaning they cannot be easily moved to different machines without significant modifications. So, lack of portability. Code is specific to a particular computer like architecture. And the error prone. The complexity of machine language makes it prone to errors, and debugging can be extremely challenging. So, error prone is high risk of mistakes due to the difficulty of working with binary coding or binary code. So, time consuming. Writing and maintaining code in machine language is a very time consuming process. Very time consuming process talaga siya ang programming in machine language because it takes a lot of time. And limited abstraction is a machine language provides little to no abstraction, requiring programmers to deal with low-level details. Limited abstraction requires handling low-level details manually. So next is the assembly language. So what is assembly language? Assembly language is a low-level programming language that provides a human-readable representation of a computer's machine code, using mnemonics and symbolic codes to represent instructions, allowing for direct hardware control and optimized performance. So, an assembly language, it replaces binary instructions with which is the zeros and ones is ma um ma-replace sa short words, which is the mnemonics here in the picture, the move, CR, and the add, which is the um, mnemonics to make coding easier. Example is the add for addition and the move for moving data. And it serves as a bridge between machine language and the higher level language or higher level programming languages. It is still close to machine language but more understandable for a programmer. So let's move. No. So how assembly language works. So instead of using zeros and ones, kakasabi ko kanina, um, it replaces from simple words like add to add to perform addition or move to move data. And these words mnemonics are translated into machine language by a program called an assembler. And the computer then executes the machine code just like it would if it had been written directly in binaries. Let's move to advantages of assembly language. Fine-grained hardware control. Assembly language allows programmers to directly interact with and control the hardware, providing a level of detail not available in higher level languages. So, Fine-grained hardware control allows programmers to interact directly with the hardware. So next is efficient code execution. Assembly code can be very efficient in terms of usage and processing speed, making it suitable for performance critical applications. So efficient code execution, faster and more memory efficient than higher level languages. Smaller code size, assembly language can often produce smaller code compared to higher level languages, which can be important for embedded systems or memory constrained environments. So it produces compact programs ideal for memory constrained environments. And then the direct memory access. Assembly language allows programmers to directly access and manipulate memory allocations, which can be useful for tasks like optimizing memory usage or working with hardware registers. So it enables direct manipulation of memory allocations. And the last one in advantages of a assembly language is the understanding hardware. Learning assembly language can provide a deeper understanding of how computers work at a fundamental level, which can be beneficial for hardware and software developers. Better understanding hardware helps programmers learn how the computer works internally. And lastly, the disadvantages of the assembly language is the platform dependency. Assembly language code is typically tied to a specific processor architecture, meaning that code written for one type of processor will not work on another without significant modifications. So, platform de- de- dependency, assembly programs are tied to a specific processor architecture. So steep learning curve. Assembly language is notoriously difficult to learn and use compared to higher level languages, requiring a strong understanding of computer architecture and assembly syntax. So, steep learning curve requires knowledge of computer architecture and a time consuming development. Writing and debugging assembly code can be a time consuming and error prone process as the programmers must manually manage memory and hardware interactions. So, time consuming development, writing and debugging assembly code is labor intensive, and the lack of portability. Assembly language code is not portable across different platforms, meaning that it cannot be easily moved from one computer to another without significant change. So, code is not easily transferable across different systems. And error prone, the complexity of assembly language and the need for manual memory management can make it prone to errors, which can be difficult to debug. Error prone, in mistakes in memory management can lead to serious errors. So, in conclusion, machine language is the foundation of computer programming, but it is developed in conclusion, machine language is the foundation of computer programming, but it is difficult for humans to use effectively. Assembly language provides a more readable way to interact with hardware while still maintaining efficiency. Both languages are essential for understanding computer systems, particularly in fields such as embedded systems and performance critical applications. This transition from machine language to assembly language represents the evolution of programming towards greater usability without compromising performance. That's all. Thank you.
Hello everyone. So the topic that we will be tackling is about high level language. So what is high level language?
So a high-level language is a computer language which can be understood by the users or which can be used by the programmers to create or write the programs to perform any complex task. Also, a high-level language is almost similar to any human language, like English, that we use to communicate with each other. So, let's relate the high-level language to human language. So, we as humans, before we can create a sentence, we first need to learn the grammars and rules of that specific language. It's exactly the same way if you want to learn any high-level programming language. For example, the C++, Java, and PHP. You must know the rules and syntax of that particular language. Every high-level language has a set of predefined words known as keywords and a set of rules known as syntax to create instructions. So if you want to write a set of instructions using a high-level language, then you must know a few keywords. So the keywords are some reserved words which are present in each and every high-level programming language. There are various keywords present in C, C++, Java, Python, and PHP. Okay, you also must know the syntaxes of each and every high-level programming language. Now, a high-level language is easier to understand for the users that the computer cannot understand it. So, a high-level language needs to be converted into low-level language to make it understandable by the computer. So, high-level language needs to be converted into low-level language to make it understandable by the computer. So, high-level code or what programmers write must be translated into low-level machine code for the computer to execute. So, we use compiler or interpreter to convert high-level language. So, compilers or interpreters are the tools that perform translation from the high-level to low-level code. Languages like Python, Fortran, C, C++, and Java are examples of high-level language. These are some popular examples of programming languages that are considered high-level. All these programming languages use human understandable language like English to write program instructions. So, HLLS or high-level languages use syntax and keywords that are resemble human language, making them easier to learn and use. These instructions are converted to low-level language by the compiler so that it can be understood by the computer. So, this reiterates that the human readable code must be translated into machine code before the computer can process it.
So here are the advantages of high-level programming language.
Writing program instruction in a high-level language is simpler and more straightforward than in low-level languages. So high-level code is easier to read and understand, making it easier to maintain and debug. Programs written in a high-level languages can typically run on different computer systems with minimal or no changes. High-level languages simplify the entire programming process from understanding concepts to creating, debugging, and modifying programs.
So here are the disadvantages of high-level programming language.
So high-level code needs to be translated, compiled, or interpreted into low-level machine code before the computer can understand and execute it. This adds an extra step in the process. Programs written in high-level languages generally run slower than those written in lower-level languages, like for example the assembly language in machine code because of the translation overhead.
Here are the examples of high-level programming language: the C++, Java, Python, JavaScript, Ruby, PHP, Swift, Go, Perl, and Fortran. And these are the most common examples: Python, C++, Java, and JavaScript. These four are widely used because of their readability, abstraction, and ease of use compared to low-level languages. Sheesh! Python. Python is a high-level programming language that is designed to be easy to read and write, even for beginners. It's often described as a general-purpose language. It simplifies coding because its syntax is straightforward and close to everyday English. Python is widely used in web development, data science, AI, and automation. Its clean syntax makes it a great choice for beginners. Here's our example code of Python. This program asks the user for their name and greets them. Prompt the user to enter their name. Name equals input, and what is your name? We use here the input or input function. It is used to pause the program and allow user to type in an answer. In our example, it asks the user, "What is your name?" and store the answer in a variable called name. The variable called name is like a data container. The variable stores what the user has typed. Let's proceed to print a greeting message within the user's name. We have here print or the print function. It is used to display or print the output. As you can see inside the parentheses, the hello plus name plus welcome to Python programming, we can see the plus operator or the concatenation. Concatenation in Python means joining two or more strings together using the plus operator or other method like fstrings and format. It means when you run this code, the output will be hello, the data that you put into the variable name, welcome to Python programming. Ta-da! Okay. Then we have here Java. Java is a high-level programming language that is designed to be versatile, secure, and easy to use. It's often referred to as a write once, run anywhere language because once you write Java code, it can run on any device or platform that supports Java without needing to change the code. This is possible thanks to the Java Virtual Machine or JVM, which acts like a bridge between the code and the device. Java is a platform-independent language commonly used in enterprise applications, Android development, and large-scale systems due to its write once, run anywhere capability. Applications made by Java are Spotify, Twitter, Minecraft, etc. Here's our example code for Java. This program calculates the sum of two numbers and displays the result. In this example code, we use the scanner to get the user's input. We use the import java.util.scanner. The program is inside a class called SumCalculator. In Java, all code must be inside a class. The main method serves as the beginning of the program. This is where all operation begins. Creating a scanner object. Create a scanner object called input to take input from the keyboard. Scanner input equals new scanner system.in. Then prompt the user to enter the two numbers. System out print enter the first number. The program provides a message telling the user to enter a number. Int num1 for the first declared variable equals input next int. The input next int reads the number. Input next int reads the number entered by user and store it in a variable. Then system out print enter the second number. Int number 2 for the second variable equals input next int. Let's calculate the sum of two numbers. Int sum equals num1 plus num2. Then we display the result, system out print. The sum of two numbers is plus sum. And those are the two examples of high-level programming language. Hee hee.
Today we will be discussing an essential topic in programming. We'll cover the three fundamental concepts, which is keywords, operators, and syntax. So these three are the foundation of writing and understanding the code. So this is the three fundamental concept of how program works. So first, let's define what is keywords. So keywords are reserved words in a programming language that have predefined meanings and cannot be used as variable names, function names, or identifiers. They are the building blocks of code, helping to define the structure and logic of a program. So keywords are reserved words which is may na siya predefined meanings. Ngan, dira na siya pwede gamiton as a variable names, function names, or identifiers. So, nano ba niya predefined meanings? So, ang keywords ko no, is man ang mga words nga may na built-in nga functions nga di mo nala hihimon is an pag-call siton nga words para maggana ang imo blocks of code, para mag-work ang imo blocks of code. Kay sa rin din nga They are building blocks of code, helping to define the structure and logic of a program. So these are the types of keywords built in Java. So we have in data type, we have int for integer, double for fractional numbers, char for character, which means you can only put single character or letter inside a single quotation mark. For boolean, it only consists of two elements, which is true or false lang, or yes or no. Then we have sa float, same line siya sa int or double, pero may da siya floating point, which is an point. Halimbawa, may da ka 1.1, that is float. Then may da pa sunod niya mga numbers. Then sa access modifiers, we have public, private, protected. So unpublic is meaning accessible by any other class, and private naman is accessible only within the declared class, and protected is accessible in the same package and subclasses. So in loops, we have if, else, switch, case, while, for, and do. So these are type of loops na we can use para mag-run or para makapag-loop ang aton program. So this is an example code or program na nagamit sa keywords in Java. So here we have public, nagamit din public, which is an access modifier. Class, para mag-declare sa class in Java. Then an loop and condition demo, which is a class name. So ini nga mga keywords mo nun essential para mag-define sa variable, pag-control sa program flow, ngan pag-implement sa object-oriented programming concepts. So now let's proceed to syntax. First, let's define what is syntax. So syntax is a set of rules that define how programs should be written in a programming language. It specifies the correct structure, format, and order of code elements such as keywords, variables, operators, and punctuations. So if the syntax is incorrect, the program will not run and will generate a syntax error. So syntax sa Java is nagre-refer ini siya sa mga set of rules nga kinahanglan sundon sa usa nga program or mao gid susunod sa usa nga program. So kung ang syntax is dire tama ang pagka or dire or waray gid sunod sin tama, dire siya kakaroton sa compiler nga mag-produce siya sa kinatawag nga syntax error para mag-prevent sa program na mag-run. So why is syntax important? So syntax is important because it makes the code understandable. Syntax makes the code readable for both programmers and computers. So it allows to communicate with computers, and computers can only understand programs written in correct syntax. So now let's understand Java syntax. A Java program consists of various elements like classes, methods, variables, loops, and statements. So each of these follows a specific syntax rule para sa dinga code. Ini siya nga code is nag-follow sa usa nga Java syntax, Java rules. So may da siya classes, which is adi nga public class hello world. May da siya method, which is an main method nga public static void main. May da siya variables, which is adi nga string and args. Then may da siya statement or arguments, which is adi nga system.out.println hello world. So these are the Java's syntax rules. So ang Java is case sensitive. So gini-differentiate niya ang naka-uppercase and naka-lowercase. And class naming naman, so dapat mag-start sa uppercase letter kapag mag-name ka sa imo class. Then sa method naming naman, dapat siya mag-start sa lowercase letter if magamit ka sa method naming. Then sa statements naman, kinahanglan may da siya semicolon, kasi if waray siya semicolon, diri magra-run ang imong program. Kay ini ang pinaka rule sa Java nga every statements must end with a semicolon. Curly braces. So, usalot ini nga kinahanglan sa Java para mag-declare sa class body para mag-run ang imo code. So, these are the example of syntax in Java. So, sini nga code is may error siya. Kay nano? Kay waray siya semicolon didi. Siring didi, error, missing semicolon. So, ang kinahanglan siya is may da siya semicolon para mag-run iton nga program. Kay pag waray siya sa semicolon, magkaka-syntax error siya. Kay ang semicolon is one of the syntax rules sa Java nga every statement must end with semicolon. So, ang syntax is nagpo-provide ini siya sa structured format sa usa nga program nga ginaalaw sa Java compiler nga i-interpret ngan i-execute ang code sintama. And that's all. Thank you.
Hi everyone, good evening. I am Crystal Ann May Summerline from Group 2, and the topic that I will be tackled tonight is the compiler and interpreter. So the compiler and interpreter are both used to translate high-level programming language into machine code, but they work differently. So, magkaiba. Para sila na can translate into high-level programming into machine code. So, ang una na i-discuss or the first that I will discussing is the compiler. So, first, what is compiler? So, a compiler is a piece of code that translates the high-level language into machine code. The compiler scans the entire program first and translate it into machine code, which will be executed by the computer processor, and the corresponding task will be performed code. So, as you can see, or as I discussed kanina, is an bogus na program is pag i-compile mo na or i-run, nakukundan siya na-translate into machine code kay nabasahan man dayon. So, ade, makikita ito sa gilid and code. And dito naman is the interpreter. So, what is interpreter? Interpreter are not much different in compiler than compilers. They also convert the high-level language into machine-readable binary equivalent. An interpreter is a program that directly executes the instruction in a high-level language without converting it into machine code. So, as we can see in my presentation, that an old example. So, as you can see in Python, once na run ka na, makikita mo na yun ang iya output sa ubos. Tapos aadala siya sa uusa nga file dire sa iba. Compiler versus interpreter. A compiler and interpreter both carry out the same purpose, convert a high-level language like C, Java, instruction into binary from which is understandable by computer hardware. They are software used to execute the high-level program and code to perform various tasks. So,